Okay, now let's look at the production method of depreciation. Okay, when we look at the production method of depreciation, we're depreciating an asset based on its use, whereas when we're looking at straight line, we just said it's based on time. When we're talking about the production, this is the type of depreciation approach that takes into consideration how that particular asset is being used in its operations. So if you remember, last class I had mentioned to you about that payloader that was used in the cotton farm and the other one that's used in the rock quarry. Using this approach, that one that would be used in the rock quarry, that the production method is going to be a little bit more stringent. It's going to be a little bit harsher. It's going to show a lot more on the wear and tear of this particular asset. Okay, so in this one, we're going to get a factor that relates to the use of the asset. And we're going to look at, again, we're going to take the residual out. We're going to take, if there's any future value, we're going to take that out of the equation because we're only going to depreciate the asset up to its residual value. And the estimated useful life is going to be based on some units. And then we're going to multiply that times the units that were produced during the actual year. So the challenge with this approach is that trying to find what is the best estimate or way to estimate the useful life of the asset. So for some types of equipment, it's easy to do. So like if you have a car, you can anticipate, well, how many miles can a car get in its useful life? And you can use that as its unit of production. If you have a delivery truck, you can estimate how many miles am I going to use that delivery truck. If I have a piece of manufacturing equipment, how many widgets can that particular kind of equipment make or produce in its useful life? Copiers, how many copies can a copier make in its useful life? So they have to have some way of estimating the asset's anticipated useful output over its life. If they can do that, then they can use this production approach in calculating the depreciation. So how they would go about doing that is, and you can see in this particular problem, this production approach, the depreciation schedule varies. And it's going to depend upon how many miles were driven in that particular year. So you can see they're dealing with a delivery truck in this particular problem. And you can see that they're taking that delivery truck in certain years and they're driving more. So therefore, the annual depreciation expense in those years is higher. So in the first year, they drove the delivery truck 20,000 miles. So they had depreciation expense of $4,000 and then accumulated yada yada. In the second year they drove 30,000, so they had more depreciation expense. But in the third year they only drove 10,000, so their depreciation expense went down. So you can see that in this approach, if they can make a determination as to a production unit that makes sense for that type of equipment, this one maybe more accurately reflects the usage of that particular piece of equipment. So in this particular approach, the formula for determining the depreciation is based on the cost of the item minus the residual value divided by the estimated units of useful life in units as opposed to years. So before, the denominator was years, and now the denominator is a useful unit of production. Does that make sense? So the denominator approach is changing. The denominator is changing. All right, so let's look at a problem. Let me pause this for a moment. We're gonna look at SE7 on page 430, and we're gonna look at a step machine that was the same one that was purchased in SE6 with the, and now we have a unit of useful life. We estimate that that particular step machine can be used for 8,000 hours.
That's a lot of hours.
And it's going to be used in the four different years in varying amounts. 1 year it's used 2,400 hours, another year 2,000 hours, another year 2,200, and another year 1,400. How much would the depreciation be for each year? So, if we look at, we're going to take that same dollar amount, 8,250 that we used in the previous. We're going to take the residual value out of the equation. So it's basically the 8,250 minus the 750. It's going to be 7,500. And now we're going to look at it and we're going to say 2,400 divided by the 8,000. Okay, so in this case, it was used, you said it was what? Point 3?
That was good, Bob.
Okay, so we get this factor here that we're then going to multiply by the 7,500.
2,250.
Wow. Boy.
2,250.
Yeah.
All right, so it's how many units it was used in that year, 2,400 hours, divided by the total estimated useful life. So just like in here, we used the 4, which was the 4 years of useful life. Now the denominator is units, 8,000 units. Okay, so let's do the next one. Again, it's going to be the 8,250 minus the 750, 7,500. And now, in the second year, how many hours was it used in the second year?
2,000.
2,000. So we're going to take 2,000 divided by 8,000, and that's
0.25.
0.25.
Yes.
So you multiply the 0.25 by,
1,875.
so it's 7,500 by the 2.25,
1,875.
1,875.
The last 3 was essential.
So what do we got, Nino, in the third year? Nino, what's the third year?
2,200 hours.
2,200 hours divided by
8,000.
8,000.
What is it, Bob?
0.275.
And so we take the 7,500 by the 2.275.
2,062 and 50 cents.
All right, we'll round it to 2,063. How's that?
I don't like that. It's wrong, but I'll allow it.
And then the fourth year. What do we have for the fourth year?
14.
1,400.
14 hours only.
And
0.175.
okay,
Multiply it by
13, 12, or 13 if we're being wrong.
13. Why would we be wrong?
all right. I'm gonna round it up.
Sig figs.
All right. So that's the production approach.